Hello everyone, my name is Saksham Purbe and this is my presentation for Lab 1. The overall purpose of this lab is to study the transfer of electrons. In particular, we'll use two tapes to estimate the number of electrons transferred between the two tapes. After getting our initial observations, we will plan on using GlowScript to model these interactions. To better understand this lab, we must become familiar with a few fundamental concepts. We begin by studying Coulomb's law, a mathematical expression that allows us to quantify the electrical force between two charged substances. In this formula, we state that the electrical force is directly proportional to K and the charges of the two substances, while it is inversely proportional to the distance squared. Here, K equals 9 times 10 to the ninth, and Q is the charge of the substances, and the R is the distance between them. We will also study Newton's second law, which states that the force is directly proportional to the mass and the acceleration of the matter we're studying. We'll use this equation to quantify the gravitational force in the experiment. We model our experiment by using two tapes that will serve as point charges to study our interactions. We'll define the system to be tape A and tape B, and the surroundings with everything around them. We charge the tapes by ripping off the tape on top of the base tape, and we can assume that the air resistance is negligible and that each piece of tape has approximately the same amount of charge spread across its surface. In our observations, we see that the charged pieces of the tape repel each other, which leads us to believe that the overall charge of the tape is a positive charge. We also do our calculations to get that the number of electrons lost is approximately 6 times 10 to the 10th, and the number of atoms per electron is 4.017 times 10 to the 6th. I'll go into these calculations a bit later in my description of the code. The data I calculated is as follows. The tape length came out to be 0.19 meters. The mass was about 0.0016 kilograms. The width was about 0.01223 meters, and the distance between the tapes was 0.2023 meters. We calculated the force of gravity by multiplying the mass of the tape with the gravitational constant being 9.8, and we derived 0.00157 newtons. We calculated the charge on tape by equating the electrical force to be equivalent to the force of gravity, and dividing that by K and R squared, and to determine the charge of the tape. We also calculate the number of electrons lost by dividing the charge of one tape by the charge of an electron to get all the number of electrons in the tape, and we do get the number of atoms per electron by dividing the total area of the tape with the total area of an atom. As seen here, this is the code. We define K as 9 times 10 to the ninth, charge of a proton to be 1.6 times 10 to the 19, G as 9.8, and here is my initial measurements. We calculate the gravitational force by multiplying the mass times G, and the electrical force as the absolute value of the gravitational force. We square root the electrical force divided by the K and the R squared value to get the Q value, because we have Q1, Q2, and we're assuming that the charges on each tape is the same. And we can get the count by dividing the overall charge by the charge of a proton. Similarly, we get the atom count by dividing the tape area by the area of an atom, and we use the code here to model and visualize our findings. The code here describes the spheres and the point charges, whereas these determine the vectors associated with the forces. Our shortcomings are as follows. The tape wasn't really a point charge, and there must have been unequal charges on the two tapes, and we could have easily lost or dissipated charges during the setup. What if? When answering these questions, we will see that the observations wouldn't have changed, since like charges still repel. Changing it to a positive charge would not change any of the findings. And why should we not touch neutral objects and handle with care? It's because the tapes would attract more electrons as they came into contact with neutral objects and overall lose their positive charge. Thank you for watching.